A pleasant day, philosophers. Today I will be discussing about induction and generalization under the study of Acuña's analysis of natural arguments and some excerpts from Hospers' An Introduction to Philosophical Analysis, 4th edition. The objective of today's discussion is to understand the meaning of induction and generalization, apply its principle, and explain its nature. Discuss the reliability of inductive inference and the required evidence in confirming many, most, almost all, and all claims, understand the requirement of a good generalization, evaluate the reliability of generalization, and to avoid fallacy of hasty generalization and understand the problem of induction. Induction is defined as using past experience to make future predictions. This means that one fact leads to another, and that we should identify what can be true so that we could focus more on the things that could be true. Inductive reasoning is the ability to rely on the predictability of nature to reveal that the future is most likely resemble the past. Strictly speaking, inductive reasoning, such that in a inductive argument, is the essence of going beyond the evidence found in the premises, meaning focusing on the things that has not yet been given as a proof. We have to analyze the content in an inductive argument to appraise its logical quality. Take note that unlike in Unit 3, there are no given classification for inductive reasoning, but still there are patterns that exist in these arguments, but these doesn't guarantee the logical quality of the argument. Let's now differentiate deductive and inductive reasoning. In deductive reasoning, true premises lead to a true conclusion, which means we get an absolute truth based on the different reasoning that is given to us. In some contexts, deductive reasoning uses a top-down approach, meaning that it goes from generic to specific. Here is an example of a deductive reasoning. Statement 1. All fruits have seeds. Statement 2. All apples are fruits. Conclusion, all apples have seeds. Let's move on in inductive reasoning. Not like in deductive, this reasoning has true premises leads to a probable conclusion, and in some contexts, it uses a bottom-up approach. Here is an example. First statement, most men in Clark has black shoes. Second statement, Josh lives in Clark. Conclusion, Josh probably has black shoes. Now, based on the different definition given, we can say that the problem in induction is that we cannot have true knowledge, because we could only make predictions to what will happen in the future based on the things we experience and know. If I go to a park and see 10 white birds flying, which then leads me to conclude that all birds are white, this makes me wrong, since not all birds are white. One solution to these kinds of problems is linguistic solution. Say that a person asks that there is no evidence that as the uniformalities of nature have been in the past, they will be in the future. Well, clearly, we could say that 1,000 times in the past, I let go of my pencil and 1,000 times it has fallen. Never once has it flown into the air or turned into powder. If this is something that they don't consider as an evidence, then what is? If the only evidence that they will only consider is something that will happen in the future, and then when it happens, it is not future anymore. Moving on to the reliability of inductive reasoning. We should know and carefully use claims in giving out statements, because just by generalizing or using claims that are not connected to our cases would lead to us being wrong. Example, from a box of 100 marbles, your goal is to know their color. You try to shake the box, which gives each marble to have equal probability to be chosen. This gives a measure of assurance that your sample will be a representative of a whole. Suppose, for example, that the color of the marble you blindly pick is white. This gives you one certain truth: the marble is white. This also gives you an inductive inference, which is a few marbles are white. You drew another 9 marbles more, and it appears to be all white again. You cannot claim that most marbles are white, since the word most uses a strict rule that it should be 50% plus 1 of the whole picture. Let's say you drew 89 more marbles, and it appears to be all white. We could then say that stating all marbles are white is truly plausible, but still it is not certain. This is because it is leaving us to one marble having the possibility to have another color. We should know the concept behind the required evidence for different level of generalization to make us literate about a certain topic. In the context of an object with 100 numbers, examples the marble scenario on the last slide, we could say that the required evidence in the claim many marbles are white is 10 marbles. 50% plus 1 for the statement most marbles are white. 80% to 90% for the claim nearly all or almost all. And a complete enumeration for the statement all marbles are white. We should also take into account that having a complete evidence to confirm your generalization doesn't create an inductive inference. The element of arguing from the observed and unobserved, or from the known and the unknown, is missing when you have a complete evidence to support a claim. Next is generalization. Generalization is defined as form of abstraction whereby common properties of specific instances are formulated as general concepts or claims. It is easy for us to generalize things without giving attention to the evidences that we could give due to human behaviors. Say an example that all crows are black based to what we observed for how many times we've seen crows, even though we know for ourselves that we cannot provide evidence to support our claim. These are some general rules when it comes to generalization. Do not say all when the evidence warrants saying only most. Do not say most when the evidence warrants only claiming few, several, or many. We can guard our claims by stating vague terms, which leads us to not be forced in showing an evidence. This means that when we are uncertain about our evidence but want to make a generalization, we could use vague terms such as many or few, depending on the cases we have, which makes other people not to disagree with us. Two requirements of a good generalization is 1. The observed cases, also known as samples, must be representative of the whole population. This is very difficult to achieve since we should always base at the whole picture. But one thing we could do, if possible, is randomizing the selection of the sample, which will ensure representativeness in our samples. Example is shaking of the box in the scenario of the marbles. And 2, no conflicting cases has been found, which means that one single counterexample in your statement could make your universal claim false. Karl Popper once stated that we do not need to verify, but rather to falsify, to look for the counterexample, although either of the two is hard to achieve. Moving on to some guidelines for generalization. 1. Are there enough cases to support your claim? You know that we do not have a definite rule as to the minimum number of cases required. The closer the number of your sample to the required evidence to establish the claim of your conclusion, the more reliable your generalization. 2. The wider the variety, the more random our selection, and the more confidence we confer upon the generalization. And 3rd, the more thorough the search, the more confidence we can place in the generalization because it seems to resist falsification. Fallacy of hasty generalization is a generalization with too few cases. This has been a very normal in our daily lives due to human wanting to do things in the easy or lazy way. Example, your Philo 1 teacher discovered that the first student he questioned is unprepared with the lesson. Based on a single example, he concluded, without further investigation, that the whole class is unprepared. This teacher has not internalized the epistemic obligation of not accepting a statement or conclusion to be true unless you have sufficient evidence for it. This is an example of a fallacy of hasty generalization. And this ends my presentation. Good day, philosophers.